In this demo, we'll look at the local custom vision API that we've built as part of the AI home security system. So in part 2, what we've done was we created a clip server that let us consume an endpoint that could accept a single image. That input image was then converted into a series of vectors. And when we had it in vector format, we could run comparisons against that. In this particular demo, we will see a .NET API that exposes two endpoints, which is train and match. The train endpoint will let us supply a label and an image, and under the hood what happens is the clip server is consumed and vectors are generated, and that vector embedding is stored. We can then consume the match endpoint, which lets us perform comparisons against data that has already been embedded. Okay, so we'll jump out of this blog and we'll see the endpoints in action. Here we're in Visual Studio, and what we can see between lines 22 and 55 are the two endpoints, train and match. We've also got some helper methods between lines 85 and 129. So we've got get clip embedding from server. So this code here is responsible for consuming the embed endpoint on the clip server, which runs on the Raspberry Pi. There's a method to find the closest match for an incoming image, and we can see that we've got a threshold of 0.85. So any image, when cosine similarity has been calculated, it must be equal to or exceed that value. And then down here we've got a method to calculate the cosine similarity between a list of vectors and parameter A and B. If we scroll up here and take a little closer look at train embeddings, we get the image and the label from the post request, and then after it's done its thing, between lines 43 and 48 we add the calculated embeddings with its label to an in-memory collection called trained embeddings. In the method post async, we accept an image in the file upload request model, and we create a local copy of that. Again, on line 69, what we do is we generate the embeddings for the incoming image using the private method get clip embedding from server, and then we compare that image and try to identify a best match. So now that we've ran through what the code basically does, we can consume each of the endpoints, and we'll use Postman to do that. So here we're in Postman, and the first thing that we have to do is to use the train endpoint to send an image for classification and labeling. So that's what we can see here. We've got a file parameter. We've set the image to Tony Stark from Iron Man, and just for completeness, this is the image. And we've set the label to Tony. We'll send that to the endpoint, and I've got some breakpoints here so we can see it's hit the train endpoint. When we get to here though, on line 41, the clip server is going to be invoked. It's running on the Pi. We can run right through and we can see that we've got a breakpoint in Visual Studio Code, and the breakpoint's been hit. For the clip server, we can expand the variables here and we can see we've got a list of all the vector embeddings for this image. We'll just run that code to completion. And then in Visual Studio, the code has fallen right through. We can then look at Postman, and we can see that the request is completed, and we get a message that says a trained embedding has been added with the label Tony. So at this point, we have submitted an image for vectorization, and we've used that to represent our training data. The next thing that we can do is to consume the match endpoint. So we'll do that by clicking over here. And this endpoint simply expects an input image. So we've already set this to one of the Simpsons characters, right? And for reference, this is the image. So we will send this to the match endpoint. And just like before, the clip server is invoked to generate vectors for this image. Then when we open Postman, it says no match found because the cosine similarity score was not above the threshold. We can test it the opposite way around by supplying the Tony Stark image again, and what we should see here is we get a match. Again, the vector embeddings are generated. And then when we look at the response in Postman, we can see that a match has been identified with a similarity of 1. So that's it. In this demo, we've seen how to supply training data using the train endpoint by attaching an image with an associated label. And we've seen how to use the match endpoint to help determine if an incoming image is a close match to any of the training data. You can find more information about this demo on the accompanying blog in the description of this video, along with a detailed walkthrough of the code and examples at jamiemaguire.net.